Morning, students. I hope all of you are fine and healthy. We have started Chapter-7, Triangle, and in the last class, I have explained about congruent of triangles, and I have given two criteria. There are four criteria. I have already given two criteria, SAS and ASA. I hope all of you understood the concept of these two criteria. Again, you will have two criteria. So that two criteria I will give you before starting exercise 7.3 or 7.4. Sorry, 7.3. Today I am going to solve exercise 7.1, and this exercise fully depend on the criteria SAS and ASA. So here you can understand how to use this criteria to solve some problems. Okay, let's start. Exercise 7.1, question number 1. In quadrilateral ABCD, AC is equal to AD and AB bisect angle A. See the given figure. So that triangle ABC congruent triangle ABD. What can you say about BC and BDs? Let us see the figure first. Here they have given AC is equal to AD and AB bisect angle A. AB bisect angle A means angle A is divided into two parts, means two angles. Suppose I have given numbers, number 1 and number 2. So this angle 1 is equal to angle 2. So first of all, we need to write what are the things they have given in the questions. So we have AC is equal to AD, AB bisect angle, that means angle 1 is equal to angle 2. Now we need to prove triangle ABC congruent triangle ABD. So here we need to write to prove, means what we are going to do. To prove what? Triangle ABC congruent triangle ABD. In triangle ABC and triangle ABD, it is given here, means see, to show these two triangle congruent, first of all we need to see their sides, then their angles. Means we have to compare their sides. This is ABC and this is ABD. So they have given AC is equal to AD. We have to see either their corresponding sides or not. See, AC, I already told you this one, AC and what? AD. Yes, they are corresponding. Also they are equal, it is given in the question. So you can use this one, AC is equal to AD. Again, see the other sides, BC and BD. In the question is they have not told about the side BC and BD. Then one more side is there, AB. It is clear here that AB is common side for the both triangle. If you can take out the AB side, then it will become a quadrilateral or not. It is a quadrilateral, but because of AB you are getting two triangles. So the AB is common side, so you can write AB is equal to AB common side. So now we have already compared the sides. Now we have to see the angles. About this angle they have not said. About this and C and D also they have not said anything. So these two angles are equal. So these are also corresponding angles. So angle 1 is equal to angle 2. Now you have to see which criteria we can use for this. We can use which criteria? Can you guess? C. For this you have to see any one of the triangles. Suppose I am taking ABC. In ABC, what are the sides or angles you have used? You have used this AC, AB and this angle. Now see, S, this angle A, then this side, means SAS. So you can write using SAS triangle ABC congruent triangle ABD. I hope all of you understood how to compare and how to see which criteria you have to use. Okay, now what can you say about BC and BD? We can see here that BC and BD are the corresponding sides of the triangle. Just now we have shown congruency. Triangle ABC and triangle ABD. BC is corresponding, BC and BD are corresponding sides. Since they are congruent, then we have the rule CPCT. corresponding parts of congruent triangles are equal. So you can write also BC is equal to BD, CP, CD. Okay, like this you have to do this. Now question number 3. AD and BC are equal, perpendiculars to a line segment AB. See the given figure so that CD bisect AB. See, AD and BC are perpendicular on AB. Means we have AD perpendicular to AB and BC perpendicular to AB. Also, it is given that AD and BC are equal perpendiculars. That means AD is equal to BC. When these perpendiculars are also equal. To prove, we need to prove CD bisect AB. CD bisect AB. That means we need to prove this bisect means equally divide, means OA is equal to OB. So to prove OB is equal to OA or OA is equal to OB. So for this now we need to choose two triangle having these are the corresponding sides, and after that we will show them congruent, then we can say these two corresponding parts are equal. See, so we are taking triangle BOC and triangle AOD. So if you write the triangle like this way, see, BOC and AOD, then this corresponding sides and angles are meeting each other. So you see triangle BOC, triangle AOD, angle BOC is angle AOD, angle BOC, these two angle. Understood? Okay, before I told you that I have to see the sides now first. Okay, so actually this is the rule. This is not a rule. First you have to choose sides or first you have to choose angles. You can compare first angles or second sides. Okay, this is not mandatory. Means we need to get the correct what criteria. So here I have chosen first angle. See, these two angles are equal. For this triangle, this angle, this for this triangle, these two angles are corresponding. They are equal. Why? Because POA, vertically opposite angle. So angle BOC, angle AOD, vertically opposite angle. Also, you can see angle CBO and angle DAO. Each what? Each 90 degree. So they are also equal. Each 90 degree. Now, this triangle have this angle and this triangle this angle. About these two angles, they have not said anything. So now you have to see the sides. About BC and AD, yes, they have said that AD is equal to BC and they are also corresponding, so AD is equal to BC given. So now what criteria you can use? See, any one of the triangle you can take. This angle you have used, this angle you have used, this side. This one is AAS, yes. Yes, in the last class I told you that you can use AAS. So using AAS, triangle BOC congruent, triangle OD. Since these two triangles are congruent, so these are the corresponding sides, so OB is equal to OA. One need to write under bracket CP, CT, so CD bisect AB. Like this you can prove. Okay. Question number 6. In the given figure, AC is equal to AE, AB is equal to AD, and angle BAD is equal to angle EAC, so that BC is equal to D. So first of all, we need to write what are the things they have given. Angle BAD is angle EAC, AC is equal to AE, AB is equal to AD. To prove BC is equal to D, this one, BC and this one, D. Now we have to choose, just now we have done like this someone, we have to choose a two triangle that containing these are the common sides. So this is why I am taking triangle, this one you have to choose by yourself, triangle BAC and triangle DA. Because BAC have BC and DA having D. So now see the sides or angles first. It is given in the question AB is equal to, you have to see AB is a corresponding side of this, means AB or AD are the corresponding side of this triangle or not? Yes. AB and AD are the corresponding side of these two triangles. So AB is equal to AD, this is given. Then also BAD and EAC. Here see angle, they have given angle BAD and angle EAC, and it is clearly you can see in the figure that angle BAD and angle EAC are not the corresponding side of triangle BAC and DAE. Yes. So now what we should do for that? See, here we have angle BAD and angle EAC. If this part, see this part, if with angle BAD you can include this part, then it will become BAC, and this side it will become EAD. Then BAC and EAD are the corresponding angles of this triangle. then we can do like that. We have, since angle BAD is angle AC, if you numbering, this is number 1, okay, numbering the angle, then you can, if you add angle 1 on the both side, it's balancing. This is also angle 1, this is also angle 1. If you transfer this angle 1 on this side, it will be minus, then angle 1 and angle 1 you can cancel. Yes or no? This line is balanced. So after adding this angle 1 on the both side, then you can see angle BAD plus angle 1, angle BAC, this angle plus angle BAD plus angle 1 it become angle BAC, and this side similarly angle EAC plus angle 1 it will become angle EAD, or sorry, angle DAE. BAC as a corresponding, if you write, then angle, if you write angle DAE, then DAC is equal to DAE. We have proved here. You can use now this one, and also it is AC is equal to AE, it is given. So AC and AE are the corresponding sides. So now what criteria you can use? So I hope all of you understood this one. Any one of the triangle you can take. BS, suppose I am taking AB we have used, AC we have used, and this angle we have used. Then means SAS. So using SAS, these two triangles are congruent. If these two triangles are congruent, BC is equal to DE. Why? Because they are the corresponding sides, CPCT. Clear? Next. Question number 8. In right triangle ABC, right angle HC, M is the midpoint of hypotenuse AB, C is joined to M and produced to a point D, such that DM is equal to CM and point D is joined to point B. So that there are 4 questions, okay. So first of all, we should try to understand the figure. According to the question, in right triangle ABC, right angle HC, this is the right angle. Then M is the midpoint of hypotenuse AB. See, this M is the midpoint of this hypotenuse AB. Maybe when I have drawn this figure, it is not matching like midpoint, but you can draw the figure correctly from the book. It is given in the book. Try to understand the concept. So M, this is a midpoint of AB, and also if so see, first of all, you see M is the midpoint. That means what? M is equal to BM. So you can write, given AM is equal to BM. Also, C is joined to M and produced to point D such that DM is equal to CM. So DM is equal to CM. C is joined to D such that CM is equal to DM. And it is given point D is joined to point B. This D to B. Clear? So these are the two things you have got. AM is equal to BM and DM is equal to CM. First of all, you need to prove triangle ABC congruent triangle BND. So to prove number 1, triangle AMC congruent triangle BMD. So in triangle AMC and triangle BMD, AM is equal to BM, it is given in the question, and AMC, this angle, and BMD, this angle, they are vertically opposite angle. So vertical opposite angles are equal. So vertical opposite angle is equal, and also it is given CM is equal to DM. So what criteria you can use? We have used this one, no? We have used AM, any one of the triangle you can take. Suppose AMC, we use AM, CM and this angle. So SAS. Using SAS, triangle AMC is congruent triangle BMD. Clear? Second one, to prove angle DBC is a right angle. Right angle means 90 degree. That means to prove angle DBC is 90 degree. See, we have already, this line is no need here. This no need. See, we have triangle AMC and triangle BMD congruent. If they are congruent, then all the parts are equal, means corresponding parts are equal, means CPCT. So that means angle ACM, this angle also equal to angle BDM. Angle ACM also equal to angle BDM. Since they are alternate angles, because see, before that, it is not given in the question that AC is parallel to BD, but we are getting these angles are alternate angles. They are equal means they are equal, and there is like there is alternate angles. Then we can say that BD is parallel to CA. BD is parallel to CA. If BD is parallel to CA, then these two lines are parallel. If these two lines are parallel, then BC is the what? Transversal. Then sum of this angle C and angle B is what? 180. According to SST means inside side of the transversal or co-interior angles. So you can write angle DBC plus DBC and ACB. DBC plus ACB 180 SST. So ACB is 90 because angle C is 90 already given. 90 is 180. So angle DBC is, if you transfer 90 on the right hand side, 180 minus 90, 90. So we got angle DBC 90. This is second one proof. Now third one, triangle DBC congruent triangle ACB. Now you have to prove triangle DBC, this triangle, and triangle ABC, this triangle you have to prove. Okay, see, in triangle DBC and triangle ACB, and we have already angle C is 90 already we have, means ACB is 90 already we have, and just now we have proof angle DBC is 90. That means angle ACB and DBC is 90. They are corresponding angles of this triangle, of these two triangle. Also you can see this BC is common, then BC is equal to CB, common side. I have written common side. Okay, and DB is equal to what? AC. Why DB is equal to AC? I have written proved, actually not proved this. DB is equal to AC. Why? Because we have already proved triangle AMC and triangle BMD. Triangle AMC have BD, triangle BMD have BE, and triangle AMC have AC. That is why you can write DB is equal to AC. So now using SAS, triangle DBC congruent triangle ACB. Okay, so you have got this one also. Now last one, to prove CM is equal to half of AB. Yes, see, already we have the proof triangle DBC congruent triangle ACB. That means what? That means we can say that all the corresponding parts of these two triangles are equal. Means AB is equal to DC. You can write AB is equal to DC because they are corresponding sides CPCT. Now AB is equal to DC. See DC clearly. DC, in DC, M is the midpoint of DC, means CM is equal to DM. So you can write twice CM. DC is equal to you can write twice CM, or also you can write twice DM. But we need CM here. That is why I have written in the place of DC twice CM. If you transfer 2 on the left hand side, it will become CM is equal to what? Half of AB. Left hand side means I mean to say like this one, AB by 2 is equal to CM. Then you can write what? CM is equal to AB by 2 means half of AB. Clear? So I hope all of you understood. Regarding this sums, if you have any doubt or confusion, you can ask me in the evening. Okay? You can feel free to ask any question if you have. And please try this homework to get positive confidence. Homework question number 2, 4, 5 and 7, exercise 7.1. Okay? And submit it in the evening. Thank you. God bless you.